All right. Well, it is 10:30 Central Standard Time, so we're going to get rolling. I'm Scott Landis, CEO of Excavation Safety Alliance, and I want to welcome everybody to today's town hall. It's going to be a pretty exciting conversation, a little different than normal, focusing on this crazy new technology that the Fiber Optic Sensing Association's kind of created to help prevent damage to buried facilities. And today's town hall is being sponsored by the Global GPR Congress, and registration is now open for the 2024 virtual event, and it's free. And we get people from all over the world, so you might want to register now while you're thinking about it. Also, today I would like to thank our Excavation Safety Alliance company members. It's a critical thing. That's basically how we finance all these free things for ESA members. And right now, we're up over 1,600 ESA members, and so the member companies are huge in that support, and it's a really big deal. And you can see we already have ESA individual members from Australia to Brazil to Sweden to Spain, so it is truly a global organization, which really helps benefit everybody sharing those ideas. So I'm pleased to have an awesome panel today. They've got a ton of knowledge in this area, and Paul is going to kind of head it off. He's been involved in fiber and everything for about 33 years and is the current chair of FOSA, and I'm sure it could make my head spin in just a couple minutes with his knowledge of fiber. But today they're going to hopefully bring it down to all of us and talk about this crazy new technology. And we really, really want people to think of questions, put them in the chat. They're going to do a little presentation first, but you put in the questions as you go, and we will get to them after they do the presentation. All right, take it away, Paul.
Thank you, Scott. I'm going to share my screen. And we'll do so right now. Okay, so before we start, I just want to thank Scott and thank the Excavation Safety Alliance for both myself and for the Fiber Optic Sensing Association being here. We're very excited to speak to you guys. You know, Scott may not be a 30-plus year telecom guy, but I'm just still learning in utilities. So utilities are very exciting, and excavation safety in general for infrastructure is super exciting to me. So I'm a novice here, so I'm hoping to learn from you guys also today as we chat. So Scott and I, met a while ago, and we started talking about this technology, and we hopefully have a great presentation panel for you guys to interact with today during our hour together. I want to start by just briefly introducing who we are before I start handing it off to some of the panelists. So I'm Paul Dickinson. I'm the Director of Business Development for Dura-Line, and I'm also the Chairman of the Fiber Optic Sensing Association. We'll talk more about that later on. With me on this very esteemed panel, I have two other members of the Fiber Optic Sensing Association, Michael Montgomery from AP Sensing, and J.J. Williams from Luna Innovations, two of our preeminent and premier companies among the many member companies we have within the Fiber Optic Sensing Association. Very pleased also to be joined by Kyle Van Landenham from Texas 811. Since you guys are in this industry, you probably know the significant role that Texas 811 plays in leadership and visionary activities with regarding 811 and damage prevention. So adding Kyle to the panel today was really wonderful, in that we not only going to talk about technology, but we're going to talk about why this is important to the industry. So with that, the plan today is a little different than I think, as Scott described to me, are done on most of these panels. We have to provide some information. We're going to try to do that in as tight a manner as possible, show you some really cool demos on how the technology works, and then allow enough time at the end to respond to your questions. So I'll remind you, as I've been reminded before, there's a chat feature here. Please go ahead and put your questions as you think of them in the chat, and we'll leave it to Scott and his team to go through and pull out the ones that we can quickly address. And hopefully we have a very interactive session toward the end. So with that, I'm going to pass the baton right now to Kyle from Texas 811, who's going to provide some context on why this topic is very important for you. So Kyle, go ahead. I'll click the next slide.
Yeah, thank you, Paul. As Paul mentioned, I am the Director of Business Development with Texas 811. Been with Texas 811 for a little over 18 years now, and Texas 811 right now is the largest one-call center in the world right now by volume. So wanted to just kind of lay some foundation here for just some of the unique challenges that we're seeing right now in our industry. So right now, as most people are seeing, damages are rising. Our current damage ratio right now has been going up a little bit over the last 3 years. We're right now sitting at about 7 damages per 1,000 tickets. And so that has continued to rise. So we're looking to address that. And right now, as it is with pretty much the entire industry, the primary cause of damage is failure to notify 811. And so that's the biggest issue right now, and I know one that we're all trying to figure out some solutions for. Another huge problem that we've seen is the on-time rates for getting the lines marked have continued to steadily decline as well. The CGA in their DIRT report actually reported that over 50% of one-call tickets are not marked on time. Right now here in the state of Texas, we tracked a little bit differently, but we're showing that about 26 to 27% of responses are coming in late. So it's a big problem. Obviously, it causes huge issues for excavators, especially when they've got, rental equipment on site, they've got staff on site, and they're sitting there waiting, multiple days to get started. So that's kind of been the catalyst for some changes in behavior that we're seeing on that side. But really, overall, we're just seeing that the demand on the system is just outpacing the supply. There's just not enough locators out there to handle the ever-increasing volume of one-call tickets. Right now in Texas, we're looking at about 4 million inbound notices to excavate this year, which is going to equate to about 25 million outbound to our member facility operators. So really what we're seeing now, which I never thought that I would see, is the lack of the 811 system and the awareness around it is not the primary problem anymore for not calling 811. We're seeing this a lot now from professional excavators that are choosing not to call, and this is for a variety of reasons, but really, what we've talked to some of these excavators about is, they have kind of lost a little bit of faith in the system over the last handful of years. They don't believe that when they process a ticket that 2 days later, those lines are going to be marked and ready for them to go. So we're seeing some really big changes on that side of things. And also, a lot of excavators are choosing speed and efficiency over doing things the right way and doing what they can to prevent damage. We're seeing that it's almost better for an excavator or an excavating company, is better for their bottom line to just blow through some of these projects and just pay for the damages later, as opposed to doing things the right way. So that's created a lot of issues as well. And also, as it is almost with everywhere else that we've seen, the system is just inundated with a lot of waste. People are trying to do things quicker, and they're processing tickets that shouldn't be processed. So that's adding to the problem as well. And then lastly, there's little incentive to do things the right way. I mean, I know here in Texas, we are in a pretty major need of some more modern legislation, and we don't really have hardly any enforcement here. And so there's really, when there's no consequences for actions, there's little incentive to start doing things the right way, and we're really starting to see that now. Next slide, Paul.
Yep, we're here.
Thank you. So really, all that being said, innovative solutions are needed, and they're needed now more than ever. I think a lot of us in this industry have always allocated a significant amount of resources to outreach and awareness, getting the 811 number out there, making sure that everybody understands that they need to call before they dig. But that's no longer really giving us the same ROI as it once did. And also some of the more traditional approaches that we see a lot of these operators and excavators. A lot of these same practices are still taking place, and we're just no longer seeing that those are working the same as they once did, because everybody else is evolving in this industry to address current problems right now. And overall, there's never really been a better time to embrace some of this new technology and innovation in our industry. You know, when I think about this industry 10 years ago, compared to what it looks like now, I mean, the amount of investment into this industry, all these new companies coming in, all this new technology being developed, it's mind-blowing how quickly it's happening. And I think that it's important that we all, you know, try and embrace some of these things to try and solve some of these new issues that we're seeing out in the industry. So, you know, a couple years ago, we introduced predictive analytics to give our members risk scores on their tickets. And we also started providing some high-risk mitigation, where we actually call out to the excavators to notify them of the high risk on their ticket and give them some actions that they can take to help mitigate risk at their job site. And for members that take part in that, you know, they're seeing more than 50% reduction in damages. And so we need things like that that can take chunks out of the damage rates as opposed to just, you know, small little steps at a time. And also, the last thing I'll mention is many solutions, they do quickly pay for themselves. I mean, when you think about the amount that we spend on repairing lines and repairing and addressing damages, and how many resources we spend to go out and monitor these sites, whether it's manually doing it, whether it's, you know, flying planes over right-of-ways, it's a significant amount, it's a significant pull on our resources. And so a lot of these technologies that you're about to hear about will quickly pay for themselves, and we're really excited to see these kind of solutions come into our industry.
Thanks, Kyle. So now you know why we're here. And I know I'm preaching to the choir big time here. So please, if I'm insulting in any way, forgive me. But you all know about damage. You know about excavation. You know about the infrastructure that gets impacted, just as Kyle described. We are here to try to introduce a technology where we would love to, as a takeaway, collaborate intensely with any one or many of you who would like to work with us on how this could work within your utility, within your business, within your support organization. So I come to you from the Fiber Optic Sensing Association. Time is tight, so I'm going to go quickly through the slide, but we're a nonprofit back in 2017 that deals with the technology I'm going to describe to you that has not been used primarily in utilities. It's not been used in your industry at all. It's been used primarily for monitoring long pipelines, transmission pipelines. It's been used for border security. It's been used for other applications. It's been around for decades, and it's very well proven. What's happening now, and the reason why we're here now, is it's emerging into areas that can benefit you. So it's emerging along roads, it's emerging along gas and electric pipelines, water pipelines, and that's the relevance of what we're going to talk about today. So I'm being a little redundant here, but I think it's good to reiterate the point that we have the 811 programs. They do a fantastic job. Scott's organization, also the Common Ground Alliance, a lot of organizations are focusing on just how do we stop these damages as we continue to build out our infrastructure from happening, or certainly lower them tremendously. So we do this through all the practices here, but there is a missing piece, and the missing piece is live right-of-way monitoring. The technologies, the ones that address this currently, are through a ticketing or a protocol process primarily. They're not through how do I stop the damage from occurring before it happens. And Kyle also just described, you can't have a camera everywhere. You can't afford to have a drone and aerial surveillance and satellite imagery and such that's real time. It's line of sight. And it's very expensive, and it's not 24/7, so there's a lot of labor and manpower associated with it. What we do know, independent of infrastructure and utilities and our underground assets that aren't telecom, is that there's fiber that's ubiquitous throughout the entire world right now. It's reducing the digital divide. There's tons of government funding out there that's going to continue to build fiber in our nation's cities, along our roads, along our utilities. and it's already there now, and there's more coming. So why not use this fiber for another purpose? So this illustration, the little blipping that I hope you see on your screen, represents the ability for an existing fiber or a new fiber in the road or along a utility or in a right-of-way to be able to sense what's going on in the local environment. And I'm going to describe just how that works in the next slide. So having fiber that's already there for your SCADA network or for broadband, it happens to be close and or right in the same right-of-way as your utility, can be used as a sensor. And it can be used as a sensor to monitor and eliminate damages, and it can also be used as a sensor to monitor operational benefits. So where no fiber exists, as you build out in the future, putting fiber in will add to this value. And let me describe how this works. And I don't want to get super technical here. We don't have time, and there's frankly not even a reason to go down that road. Fiber is used right now with laser pulses to provide our internet, the broadband, right? So you send laser down one end, you have information that comes out the other. This is why we have a capillary system of fiber throughout the world. But the same fiber that's used for telecom right now can be used for an entirely different purpose. And that purpose is to turn the fiber along its length into a distributed sensor. That distributed sensor is extremely sensitive and can actually detect if someone is adjacent to the right-of-way, opening a manhole or tapping with a shovel or digging up the ground with an excavator. And as Kyle and others have talked about with the fiber optic sensing organization very extensively, sometimes there's an 811 ticket for doing that. Sometimes there's not an 811 ticket for doing that. What this technology does is it enables you to identify within a very short distance along the route of the fiber. We're talking, 5, 10, 20, 30 feet, that something is going on, and it can actually, through the software, identify what it is that's going on. That's tremendously powerful. And it's monitoring for vibrations. There's also the capability, and it's probably not quite as relevant to you guys, for damages, to monitor for temperature and strain. But what it does, and you're going to see some wonderful, colorful charts in a few minutes as we're going to go through them very quickly. What it does is it pulls up an alert on a map. And that alert on a map will show you something's happening, and it's able to send out an automated text or an email or response to get people to respond. So that's the gist of the technology. It goes into a command center. While you may get wonderful analysis that gets into quite detail, like on the left side of this chart, what is really important for a utility or for a telecom or anyone else who's interested in monitoring their assets is knowing something's happening at this location on my GIS map, and I either know about it and I'm okay with it, or I'm not okay about it and I've got to do something about it quickly, or I'm going to have a problem. So with that, I'm going to pass on, and we're going to click through some really nice demonstrations that just give you an idea, and hopefully you can hear the sound. Turn up your sound if you need to on some of these applications. I'm going to hand it over to Michael Montgomery from AP Sensing, and we're gonna go through a few. Go ahead, Michael.
Thanks, Paul. I appreciate that, and thank everyone for joining this discussion and allowing us to present this information to you. AP Sensing is one of the manufacturers of the monitoring control systems that can connect to an optical fiber that's already in the ground and turn it into a sensor to detect acoustic or temperature activity. The system has the ability to detect a variety of different elements. The key problems that you already see that are causing operational and damage issues fall into categories like the ones that you see on the screen here. Next, Paul. These kinds of things can be readily detected. Paul, next. Can be readily detected using fiber optic sensing technology. This is an example of the acoustic signal that is detected and located in response to an excavator digging a hole in the ground near an underground utility. Next, Paul. The same kind of detection can be triggered by other events. This is an example of detection of gunshot activity. A surface gunshot movement can cause an acoustic burst that the system can detect. So things like explosions can very readily be detected by this kind of acoustic monitoring technology. We'll wait just a moment for the explosion to occur and then switch to the next slide. There's the explosion and the much broader element of the acoustic disturbance that you could see. This is an illustration of a pipeline leak detection. So for example, if a utility is operating a high pressure fluid filled electric conductor under the ground and that pipe develops a leak, the acoustic monitoring or temperature monitoring technology can detect that kind of activity and generate a report showing the exact location. Next, Paul. These are examples of different kinds of detection capability. This is an example of the acoustic signal generated by a concrete saw cutting through an asphalt street surface. Provides a very recognizable signature that can readily be detected, analyzed, and located. Next. As you can see from these examples, the systems not only detect the acoustic energy and plot its exact location on a geospatial map, but they can even identify what particular disturbance is being classified. It can tell the difference between a jackhammer digging in the street, an excavator digging in the ground, or a saw cutting through a concrete pad. These are all readily recognizable and reportable disturbances that can be accurately located along a utility path. Next, please. This is worth looking at because among the things that this technology can detect is the passage of rail and vehicle traffic. I'd like to point out here that although you can see a very strong acoustic signal in the acoustic diagram to the left, this did not cause the generation of an alarm because the system had been programmed to recognize vehicle and train traffic as a normal urban event and not generate a nuisance or false alarm because of that passage. Next, please. After those technology demonstrations, we can see that this kind of technology can very readily detect intrusion attempts, but distributed fiber optic sensing can also monitor and report on operational issues that potentially can lead to damage, such as the overall distributed temperature of an underground power cable, temperatures of joints and hot spots, and other events that relate to the operational condition of underground utilities, including power, water, sewer, and many other kinds of utility operations. Next, please. We have a couple of quick displays here that simply shows some typical deployment and case studies. This is an example of a deployment where an acoustic monitoring system was used to provide on real-time monitoring of an underground power cable network to be able to rapidly and accurately detect digging activity anywhere along the underground cable's path. This can prevent damage to the cable even in cases where someone does not or avoids calling 811 to get permission. This kind of technology can detect potential damage before it occurs. Next, please. Similarly, a combination of acoustic and temperature monitoring technology can provide multi-purpose monitoring. In this example, a combination of an acoustic monitoring system and a temperature monitoring system is providing monitoring capability for this undersea cable from an offshore wind farm to detect the presence of things like ship and anchor traffic while still performing or providing 24/7 temperature monitoring capability, showing the conductor's ampacity and things that can affect the ability to conduct current. Next, please.
Okay, thanks, Michael. Appreciate it. So before we go on, I want to make a comment here because we're showing you a lot of stuff quickly, but I mean, that's why we want to just give you a flavor of what the technology can do. The important point I perhaps didn't make earlier is this is a passive detection system. So in other words, you have fiber cable under the ground that's maybe going on for 25, 30 miles in one direction. The only electrical unit that's providing the laser pulses sits safely in a little rack of equipment somewhere 25, 30, 40 miles away. So we're talking about a very long capability of monitoring an asset without putting things in the field that don't have to be adjusted or monitored or calibrated over time. So I just want you to get that idea in your mind as I pass it over to JJ Williams to show you a few more examples, and then we're going to tie it all together and get ready for questions. Go ahead, JJ.
Thanks, Paul. Good to be here with everybody. If you can pause that for a second, Paul. Thank you. I'm JJ Williams from Luna. We're a manufacturer of fiber optic sensing systems out of the USA, headquarters in Virginia. My office is out of Houston, Texas. And between OptiSense and Lios, we have around 100,000 miles of infrastructure monitoring systems installed around the world, providing temperature and acoustic monitoring. And I'm going to give you some examples here of installations and applications for damage prevention. So this is actually an aerial line where we're monitoring the dark fiber in the OPGW cable. It's like 30 feet up in the air at the top of these towers. And, you know, sometimes you get accidental damage or intentional damage in some parts of the world. You know, people, you know, sabotage or stealing cables and things like that. So we're monitoring that and providing an automated alarm to the operator. And we can also provide automated alarms to call centers. Next slide, please. Con Ed in New York have transmission and distribution lines that they want to protect. They also want to set up a zone around each of their manholes and have an alarm if anybody opens a manhole, you know, so that they can see that it's either their own maintenance crew or, you know, an unscheduled event which they want to investigate. So that's the ability of the system to have the granularity to say, right, in this location, we have an access point, like a head end or a manhole or something like that, where we want to have specific monitoring capability. Next slide. This is an example in a rural setting where the locators out surveying made a mistake, and instead of measuring away from a large diameter pipeline, they measured towards it, which is, you know, human error. And we were picking up digging alarms over an extended period of time, and the operator went out and investigated and found they were digging the foundations for a cell tower, for a wireless tower. So that was quite a scary event. And even though they were permitted, they messed up on the locate. Next slide, please. And another example, you know, this is unpermitted construction. So they were building houses that were, you know, completely unpermitted in a remote area outside a city. And you know, we were picking up them dumping huge amounts of soil, getting ready for a major construction effort that was completely illegal. So that's another example. So all these systems, you know, are very, very configurable to what kind of fiber you have out there, you know, be installed in conduit or in a duct bank. It could be 20 years old. You know, I talked about that 100,000 miles of installations we have around the world. I would say about 80% of that has been on, you know, 10, 20, 30-year-old fiber. And when you set these systems up, you need to configure them to detect what is a threat to a buried or aerial asset, and then ignore other noises in the environment that are just, you know, the daily pattern of life in a city, for example. So we do these things called site acceptance tests, where we configure the system to what the operator wants. This is up in the Northeast. I think this was actually in Toronto, where we, you know, for every installation we do site acceptance tests saying, is the system alarming in the way that the operator or asset owner wants, and in terms of what is a threat. and is that coming into their control room or into the call center in the correct way? So we do these tests, and we do ongoing support. As a vendor, all vendors provide ongoing support for operators who have these systems deployed. Okay, so this is just another example. So, when you're planning utility or other investments, fiber rollout, broadband rollout, consider this technology. Consider how it can be used to monitor for both the damage prevention and the operational benefits that Michael described. With this little bit of pre-planning, it's not a huge, delta on the investment, but you can get all of these benefits that make these assets safer for the public, longer lasting, and so forth. Back to you, Paul.
Yeah, thanks. So let me try to tie it up because I really want to roll over to questions very, very quickly. I come from a company that is the world's largest provider of conduit, are the pathways that optical fiber go in. So we're aware of just how much fiber and conduit there really is throughout the world. There's a tremendous amount. Not every utility currently has fiber next to it, but an awful lot do. And for power utilities, a lot of times, you've got your conduit, you've got your conductors, but you don't currently have fiber adjacent. The point of this conversation is that in many cases, the fiber's already there, and it's already there in the same fiber, nothing special. The same fiber with just some added electronics can do an entirely new purpose than just your SCADA purposes or your broadband that you probably weren't aware of until this talk. Probably the more important thing is, as you continue to build out new routes, and we all know we need that in the US and globally, the addition of a small amount of conduit and fiber alongside your asset will hopefully provide tremendous return on investment for you above and beyond everything else you're doing. So it can be an economical solution. We'd love to talk to you as a utility or a funder or whoever, or a city planner or whomever is interested in how this technology can work for you. It can reduce your damages significantly, especially if you're providing them on critical routes where you typically have a lot of damage. As JJ mentioned, operationally, it provides so many other value added ways to monitor your assets in productive ways, so you could do proactive maintenance in addition to just stopping damage from happening. So it's really a key enabler that I think a lot of people are just coming into awareness now that can be coupled with an 811 program, as Kyle mentioned. So just a summary here, and then I'm going to show you our contact information. Then I want to get into Q&A. Damages are clear. I mean, that's why one of the reasons why this organization exists. It's a well-documented problem. They're not going away anytime in the future. In fact, they're going to get worse because we're building out more infrastructure with not so great as-built under the ground, where you're not sure of either live assets or assets that are no longer live exist. You're going to continue to have problems. You're going to continue to have life safety events. I don't need to tell you that. That's what this organization does. But with this technology, you have the ability for the first time for proactive right-of-way monitoring. And if it's done in an intelligent way, at a lowest level, it can impact you directly as a utility, and you can benefit from that. But if it's done in a collaborative way, it could actually benefit an entire right-of-way with multiple utilities. So there's cost sharing. It's easy to deploy. I showed you probably in 3 minutes how the technology works, but basically it's hardware, software, and it's passive fiber for many, many miles, or whatever miles you need. And it works, and it's widely deployed. So we showed you, JJ and Michael showed you today, there's many instances around the world where it's demonstrated. What we'd like to do is get folks like yourself who look at their network and take a hard look at it and go, where could I implement this? And where would it benefit me from a life safety and a financial perspective? So, think about this in your new builds. Please reach out to us. This is just an example by the member companies that were on this call of some of the folks that they are working with right now. I won't spend any time on this, but there are folks out there now where they're looking at implementing it. And this is our contact information. So I encourage you to, think about this when the archive comes out, share the archive amongst your friends, talk about it within your organizations, and then say, okay, I'd like to take this a little further, and I'd like to reach out to Paul at FOSA and the rest of the panel members, and let us work with you and try to determine, how this business case works for you and can help you with your assets. So with that, we're not too bad. We're 35 minutes in. I had promised the Excavation Safety Alliance we do this in 30. This is the fastest we've ever shown those demos. So hopefully you're all still awake. And let's get into some Q&A.
Yeah, Paul, great. Thanks. That was very informative. And even though I've seen it once before, not at this lightning speed, it was still helpful to get a grip on it. A couple of questions that are out there are, how does it locate different utilities, and does it give an XYZ position?
I can address that. I
can
can address that if you like as a first, and then JJ might have some additional, because we both kind of do the same thing in slightly different ways. The second part first, the mapping of a fiber optic based system throughout a network path is integrated through geospatial positioning. So the graphic display of for example, the map of an underground power cable is mapped with GPS coordinates. The systems are able to very accurately measure and locate the linear distance from a controlled device to the point of a disturbance. And then that is plugged in to the geospatial integration so that it can show up with specific latitude and longitude coordinates on a geospatial map. So that can be done very accurately, so that the Utility Operations Center, when a disturbance comes in, almost instantly gets a display of virtually the street address of the location of the disturbance. It can be very fast and very accurate. By itself, it doesn't identify different utilities. It doesn't necessarily identify what the utility is, but it would be able to map different paths using different fiber optic circuits that are deployed along with different utilities, and of course be able to tell the difference between them. JJ, anything to add?
Yeah, I would say it's more damage prevention system, and we know the location linearly quite accurately. But when you're trying to get depth of burial, or where the fiber is related to somebody banging on the ground or something like that, we can get a certain amount of accuracy for fiber locate. How deep is the fiber and things like that. But we're not talking inches. We may be within a foot or a couple of feet or something like that. So it's not really a locate technology as such. It's more of a damage prevention technology.
Yeah. So JJ, I think if I understand it right, so this is really an activity alert. It doesn't replace the actual locate, right? Correct.
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 Yeah.
Which is
in fact,
huge plus.
Yeah, in fact, Scott, I'll answer the next question along those lines just as a carry through. So, Duraline makes conduit. This is some of our more modern conduit called Future Path, which has multiple pathways and all kinds of cool stuff in it. And we continue to put tracer wire in the conduit because that's a common way to locate, right? And I know a lot of states mandate, because I've learned a little bit about this industry, that the last potholing and everything else needs to be done. They don't get around that right now. But the question I'm reading here right now is, in new construction, would this be in addition to placing a tracer wire tape with the asset? And my short answer would be yes. We found that sometimes the tracer wires, over time are not there, even though we do our best to install properly. And they're not always reliable, even though they are the most reliable means of locating right now a plastic asset. So the vision that I have, and I think we have within FOSA, is that once companies on this call realize the value add of everything they can do operationally by using that fiber next to their asset, and everything they can do from a damage prevention to lower their damages and life safety events, then they will then say, just like the oil and gas industry does now, I'm not going to build out new assets without making sure that I have conduit and fiber in there, because it doesn't make sense not to. And then while they're putting that conduit and fiber in there, they might as well put it in enough that they can use it for leasing, for broadband, whatever else. So we're all about multi-use, and multi-use to leverage your right of way and your asset just as much as you possibly can to not only keep your asset running, but to monetize it going forward for other reasons.
Yeah, I would just add, in new construction, getting that trench open is what's expensive. The fiber, getting a fiber in is cents on the dollar, and is a very, very good investment for damage prevention, but also telemetry. But most right of ways, it could be 8 feet away on the edge of the right of way. Most right of ways have a dark fiber. It may be owned by somebody else, but we can, contact them, and it's a win-win for shared right of ways to monitor them for damage.
Yeah.
So that's just something but yeah, you need it in addition to tracer tape.
One more quick follow-up before I forget it. I apologize, and I'll turn it back to Kyle and Michael. And when you have a power conduit under the ground, you may not have fiber near that power conduit, but it may be existing, right? So you don't even need to dig up the ground at all. You could blow in a small amount of conduit and fiber in along that interstitial space along with the power. And now what have you done? You put in the capability to monitor the temperature of that conductor. You put in the capability to listen for sparks or weld points in the fiber that they're going to be the weak points going forward. And you have a damage prevention. I can hear everything going around my right of way just for doing that. So existing assets, you could literally just add a small amount of fiber, jet it in, and you've now done something that nobody else has. You've lowered your need to monitor this asset. It's amazing.
As well as providing a communication channel. Let's not overlook that all of this is multi-use capability. If there's already a cable there for communications or telemetry, as JJ mentioned, there's a high probability that there is an existing spare fiber that can be used for sensing purposes. A fiber optic cable that's deployed primarily for sensing virtually automatically provides additional communication and telemetry access. So in almost all cases, it becomes a multi-benefit situation.
That's great. There's a bunch more questions in there. Paul, do you see some of the technical ones?
Which one?
Let's see. The one with the majority of new utility asset installations via HDD creating issues with tracer wire installation. Has FOSA any recommendations on installing processes to reduce excessive bending or flexing?
Oh yeah, okay. So since I'm a fiber guy too, I'll mention that. That's a long question. I guess I'll answer it by saying, don't worry, because the installation processes are out there for that. I mean, basically, the way the industry is going is people are less and less just burying fiber cable. I mean, this sounds like a conduit plug, and maybe it is, but it's reality. Most fiber installations are going in conduit. And the way conduit works is you interconnect the conduit like Tinker Toys. You make a long continuous path, and then you have a safe protective path where you jet in the fiber cable in these interstitial spaces. When you do that, you're not going to be in a situation where you're going to have bending. So the only situation where you're going to have bending is your connectorization in the manholes, your splice points and things like that. And there are protocols in the industry for that. So that's a whole conversation for another day. I guess I would just say that there's industry information out there to minimize fiber bending. It's not of concern. It's done day in, day out. So if you're a utility who's just not too familiar with conduit and fiber, again, reach out to myself and the panelists. We'd be happy to help you with that. But the telecom does this day in, day out. Otherwise, we wouldn't have a broadband and an internet. So I hope that answered your question.
Fiber optic cable also tends to be a lot more flexible than a lot of the electrical conductors that you're already dealing with. So while there are bending limitations, I mean, all fiber optic cable has minimum bend radius requirements. They tend to be looser than a lot of the other technologies that you work with. The installation process itself provides the resources to, during the installation process, monitor that and then qualify it by very basic testing before you try to activate it.
Here's another technical one. Similarly, do you have any recommendations to limit signal attenuations due to segment spans? I'll pass it over to our esteemed other colleagues here, but I will say this, that there's a loss budget involved. It's not that demanding. And just based on doing good splices in your fiber and following standard telecom protocols, I don't see that being an issue, but maybe somebody else can answer that in a different way.
Well, there are definitely installation methodologies that need to be adhered to. But with that said, the types of optical fiber that can be used for these kind of deployments supports long distance communications. I know that AP sensing for telemetry purposes for even the basic temperature monitoring systems offers systems that can work with multi-mode or single mode fiber. Single mode fiber allows the deployment of fiber spans in the tens of miles range. So the attenuation that's inherent in fiber tends to well support this kind of long distance applications. As long as Paul mentioned, you use reasonable care to make sure that when you splice segments together, the loss of the splice falls within the acceptable criteria.
Did we lose JJ, or JJ, do you want to grab one off the chat?
I think
we
you
lost
mentioned
him.
he lost.
Okay, we lost him for a
Sam.
second. I'll answer this DOT one, which is interesting. So, I mean, we're talking primarily protection and damage protection of electric utilities, gas utilities, water utilities. But it's interesting that somebody here has a comment on DOT. So I'll briefly make a comment on DOTs. That goes a little bit off the rails here. So there's tons of fiber and conduit being put along our nation's roads. We know that. Sometimes it's being put in for broadband. Sometimes it's being put in for a DOT who specifically just wants to connect their cameras and connect all their devices. And or some of the innovative ones are actually putting in fiber and cable conduit like this to lease fiber and use it as another way to, get a return. What's interesting about this technology, we didn't address it on this talk at all, is this also has the capability to monitor traffic. So this technology can, and this is a talk for another day, this technology can be used to monitor traffic and speed alongside your road. One piece of fiber on both sides, one side of the road can monitor both sides of the traffic and can be used to supplement your capabilities for cameras and induction loops and infrared sensors, and actually lower that industry's operating and maintenance costs. So in addition to protecting the right of way, again, always protecting the right of way, someone's trying to do something to it, you can detect ahead of time it's going to happen. So to the person who, Patrick Sharon, who asked about DOTs, this is applicable very much so along our nation's highways. JJ, go ahead. Grab a question. If you're there, your bandwidth looks a little fuzzy. Are you with us?
Well, I have a quick question, Paul, while JJ sorts through one of those. Is it, I think this is a dumb question, but this sensing, does it use any of the bandwidth on the fiber, or is it separate from that?
I'll address that. Looks like JJ dropped off again. The use of a fiber in a cable for sensing purposes uses that fiber exclusively. So a fiber optic cable will have multiple fibers, most of which are used for telemetry or communications. A connection to it for sensing occupies that fiber by itself. It's not shared for other use, but other fibers in the cable are then available for any other kind of telemetry or communication applications.
Yeah, and I'll add to that, this industry is evolving, and that's why it's exciting for you guys to be hearing about this right now. As Michael just said, fiber usually is put in cables that have 144 count to as high as 864, and then there's multiple cables on top of that. So there's usually tons of fiber. It's very rare you have a fiber limited situation, except maybe in transoceanic, where every fiber is critical because it's just such a long distance. So typically, and I would say 98% of the cases, you just dedicate one fiber to this technology. Now, that said, if you ever get in a situation down the road and you've implemented this and you love it, it's working within your utility, there are folks that are looking at using a particular wavelength in a band. Oh, you just got to make sure it doesn't impact with your C or your L band telecommunication. But for the purposes of this discussion, just dedicate a fiber, a standard fiber that you already got on the ground or you're going to put in for telecom, and it's going to work great.
Yep.
Kind of a related dumb question from me. I'm going to assume this works, but you know that abandoned cables and pipes are a big issue in the industry. And I assume if there was an abandoned pipeline in particular, it would be easy since maybe there's no duct, but you can shoot the fiber down the empty pipeline and boom.
Yeah, Scott, well, what I was just telling before as an idea and a vision of putting a small amount of conduit and fiber cable adjacent to power cables, is exactly the same concept. In fact, I've talked to folks in the past who had large abandoned pipelines that they wanted to use them as essentially like a telecommunications conduit, right? Because it's already in the ground. They don't have to dig. They can jet in, conduits like this and then now subdivide and use this for leasing. Just by doing what you just described, you're exactly spot on. You can then use that as a way to locate. Now, there's a bunch of locate questions in here. I don't want to minimize the fact that this can help locating. Okay, so even though it's not maybe necessarily your last potholing or your last, I'm going to verify within 2 inches that it's exactly here, those locating companies who may be on this call, who think about the manpower and the resources, and Kyle has educated me the fact that we're limited to resources in general with respect to locating, and that's why people go around the 811 ticket system. Having the ability to know to some level of accuracy that I've got a fiber cable here and a conduit here versus on the other side of the street, because I can see it on my map by tapping the ground, that can have tremendous manpower savings and validate as-built maps, right? So there is an element that a locating company could use here by lighting up, so to speak, fiber in a route and then saying, now I can approximate or come very close to where it is before I do the final check.
And in fact, route tracing and route validation are a couple of industry terms that as manufacturers we've encountered, especially in the telecom and networking industry, as a tool to be able to successfully verify installation documentation from an installing contractor and verifying the accuracy, because it does allow you, using acoustic sensing technology, to be able to generate a surface acoustic signal and measure the amplitude of that signal on an underground fiber optic cable and verify that it's within a certain distance of where you're generating the noise. Even if there is no tracing methodology provided, or if the cable is buried too deeply for electromagnetic tracing to work. So yeah, it definitely does provide that capability. As JJ already responded to a question from Brenda and from others, yes, it's very much a part of it. Also, when we're talking about connecting to fibers, nobody has really mentioned the increasing prevalence in the underground cable industry of deploying high voltage conductors that already have embedded fibers in the cable structure, woven into the outer shield, replacing some of the wires on the outer shield. Those kind of cables, such as XLPE conductors, are already equipped with sensing technology. All you have to do is to connect a monitoring controller to one end of a segment that could be many miles in length, and you have a plug and play monitoring system for both temperature and acoustic detection capability.
JJ, if you're back, or Kyle, please jump in here. And anything you'd like to grab.
It does sound like a quick question and answer is, Brenda is asking if the fiber all has to be buried or if it can be aerial. I'm guessing it has to be buried, or can it still sense if it's aerial?
If you're sensing things in the ground, then you would want to have buried fiber cable, but there is an entirely different application space for aerial, right? So if you have an aerial distributed network, you have the same capabilities with the aerial to use this technology to monitor things like galloping, to monitor. I mean, look at what happened in Hawaii, right? We all saw the very unfortunate series of events. Had that fiber cable aerially been monitored, with this technology, in my opinion, not knowing all the details, so there's my legal caveat, then you might have indication that the lines were coming down very quickly by using technology like this. JJ, if you're back with enough audio capability to jump in, please do.
Yeah, aerial lines are monitored as well, and we can definitely see where buried lines become aerial lines and help you differentiate that. And yeah, for aerial lines, it's a noisier environment, so you need to be very prescriptive about, you know, what you're trying to detect. And it's going to be, you know, significant interference with the cable, you know, the cable structure. You know, because we don't want to be reporting on every gust of wind and every time somebody bangs into a pole. Maybe you do want to know that, but you know, you need to be quite prescriptive about what you're alarming on for aerial lines. For buried lines, you know, you're coupled with the soil or the conduit, and it's, you know, easier. You're buried. You know, it's an easier environment to set up these detectors.
Yeah, somebody asked me to put the slide up again. I guess they missed it, but it will be in the archive. So these are the folks you should reach out to and have a conversation with going forward. And I don't want to cut into your final few minutes, Scott, but if you see another burning question out there you want us to address, please let us know.
Yeah, there's probably one here, and then we are gonna have to move to wrap up. But it's kind of a long one, but it basically is about the average cost of repair. And I think if I'm reading right, the concern is if they put this next to a gas line and now something gets hit, they're looking to see, so now what would it cost to repair the two things? And if I'm understanding that right, I mean,
right. Well, the whole point is
it doesn't happen.
Yeah, the whole point is damage prevention, right? So we should be providing very early warning of, you know, when somebody comes onto the right of way with construction machinery, you know, and alarming on that rather than somebody's hit your pipe or somebody's broken your cable, because by then it's too late. So, you know, early warning is the key, and it's all about damage prevention. And if there is damage to the fiber, we will detect it, we will locate it very accurately. And, you know, for fiber restoration, it really is just splice. There's many splicing engineers, telecom engineers, you know, who can be there at short notice and splice a cable within a few hours.
Yeah, so that would be actually helpful, because if your fiber's hit and your gas lines hit, this at least tells you exactly where your gas is probably hit as well, or very close. So
that's right.
Yeah,
Right.
and something else that I wanted to add to that real quick too,
and things like that.
Is that, I mean, just looking at our mapping system and seeing how congested a lot of these right-of-ways are with all different types of utilities owned by all different, you know, utility operators. One of the great things about this is if there's a fiber actively running through there, sensing excavation activity and things like that, you're not only talking about protecting one facility, right? You're protecting everything within that right-of-way. So if you do have an unauthorized excavation out there, where maybe an excavator doesn't have a one-call ticket, and you go out there to respond to that to protect your line, well, you know, you're also protecting everybody else's facilities that are also in or along that right-of-way as well.
That's right. So Scott, thanks on behalf of everyone on this panel for this opportunity, but let's not have it stop here. The whole reason we did this is, okay, everyone out there who's still listening, please reach out to us. Let us work with you and show you how the damage prevention that's capable from this technology could financially pay for itself, and more so. So that's really the thrust. And back to you, Scott.
Agreed. Great. Yeah, new technology is really needed in this industry, and this is a great example of how we can lower damage through new technology. So I want to thank you all for being panel members, and for everybody for joining. And I will say there's going to be a brief survey in the chat here. Excuse me. So it'd be awesome if you fill out the survey. It helps us see what we're doing right, and give us ideas for new topics. So anyway, I'd like to thank everybody for joining, and remind everybody also that our next town hall is December 14th, coming up quick. So register for that now on vacuum excavation. And also, we do have a first-time attendee special for our conference in March, which ends on the 17th of this month. So take advantage of that. And with that, I just want to thank everybody and thank GPR Global Congress for being the sponsor. So thanks, everybody. Have a good day.
Thank you.